Thanks, Jesse, and good morning, everyone. Welcome to this webinar about using Mapbox satellite and aerial imagery to solve problems. So my name is Charlie. I'm an engineer on this imagery team at Mapbox, and today I'll be outlining some basics of imagery and Mapbox's imagery products. Then we'll cover some examples of problems that imagery can address, and at the end we'll have time for questions. Mapbox is a location data platform for mobile and web applications. Mapbox's products are building blocks that add location-based features such as maps, search, navigation, into any application with support for iOS, Android, web, Qt, Linux, or Unity. 1.6 million developers are working with our tools around the world, reaching more than 600 million monthly active users. These are some of the apps powered by Mapbox, including Lonely Planet, Tableau, National Park Service, Red Bull, Weather Channel, Hotels.com. So let's talk about imagery specifically. For our purposes today, imagery is any collection of useful photographs of the Earth. That's a very broad definition, but it fits the kinds of services we provide because we see people with a very broad range of needs. When we talk about imagery at Mapbox, we're really talking about two products or groups of products. One is the imagery base map, which is a global imagery layer that we curate and supply. And on the other hand, there's imagery that you bring to the platform. These both fit under the umbrella of imagery, and they're equally important to different projects. Sometimes I talk to people who want to know about imagery, and halfway through the conversation, I realize they're really only thinking about one or the other of these. So I think it's worth saying up front that these are both under the heading of imagery. Let's start by talking about the base map. The imagery base map is global, covering the whole world from London to Fiji, multi-resolution, from global scale to seeing details on streets, and curated, meaning we've chosen from among hundreds of imagery sources to stitch together a good general purpose imagery map. And for developers, the map ID is Mapbox.satellite, and that's really all you need to know. You can put that map ID pretty much anywhere that another map ID could go, and you've got imagery on your map. It's right there in Studio. You can just click and get started. And of course, there's no extra cost for using the imagery base map. It's part of the package you're getting with your Mapbox account. There's nothing special you have to do to get access. Now, the fact that its map ID is Mapbox.satellite brings up an important point, which is that we refer to imagery as satellite a lot. We say things like, this map might work better as a satellite map, for example, but that's a little bit imprecise. What we're looking at on the base map here, for example, is aerial imagery taken from an airplane. This is the kind of imagery you'll see in, for example, a lot of big cities in the US, also a lot of New Zealand. There's even a little bit of imagery from UAVs on our base map, which you could call aerial or you could just call UAV imagery. In general, aerial imagery is sharper than satellite imagery, but it's not available over areas as wide or as frequently updated. So we use it where it makes sense. This is an image of Philadelphia where we've chosen and bought some nice aerial imagery for our base map. In the bigger picture, the differences between imagery sources include satellite versus aerial, but also things like different satellite sensors, different hardware platforms, different aerial sources. In general, these are the issues that we deal with so you don't have to. We track down the best available imagery for a given place. We evaluate trade-offs between things like resolution and recency, and we make a base map so you don't have to consider these issues. This is why I emphasize that the base map is curated. It's got a lot of common sense decisions baked into it that you're probably not interested in spending your time on when you could be thinking about your projects and products. That's a lot of the value of the imagery base map right there. But, of course, there are situations where you would rather make your own decisions. Situations, for example, where you need a specific type of imagery or even very specific images to do your work. So now we're back at this division of what Mapbox provides versus what we make it easy for you to upload yourself. But we can also split this another way, adding a second dimension. So we're preserving this distinction between what Mapbox provides versus what you provide, but we're adding a distinction between situations where imagery is central to the project versus situations where it's merely complementary. So in some cases, imagery is just a backdrop that adds value to a product that isn't really about imagery. These uses of imagery are still important. They just aren't focused on the imagery itself. And then there are cases where what you're doing is really about the imagery, where you're showcasing what things actually look like, or running automated processes to learn something about imagery, using imagery to make your own maps, things like this. These can be user-facing products, or they might be running behind the scenes to do things like feature extraction. Most of the rest of this webinar will be a tour of these quadrants, looking at real or demonstration applications that fall in each of these 4 categories. The goal is to make sure that you get some sense of the range of possibilities with imagery, to kick off some conversations about how it can work for you in ways that you might not already have thought of. You can keep this chart in mind to track the ground we're covering. I'm going to start with a relatively simple example. In fact, it's one of the tutorials on our site on georeferencing imagery. What we have here in the screenshot is just a scanned image of a historical map. You can find thousands of others like it. And you can manually georeference that, which just means to assign it coordinates using matching locations or the reticle on the map so that it can be rendered at the right place in the world. For imagery that's already georeferenced, like most commercial or open geospatial images from, let's say, Maxar, Nearmap, Landsat, any of dozens of other sources, that middle step of georeferencing isn't even necessary. But once it's uploaded, you can plug it in, you can plug it into, there we go. Once it's uploaded, you can plug it into a huge range of templates or develop your own display or analysis tools. Here, working from that demo, we have a split screen comparison with a current street map. That's the Mapbox street layer on the left and the user uploaded imagery on the right. Of course, you could just have the historical map with no comparison, or you might have an image that you collected, let's say from a UAV in October as the before, and similar imagery from December as the after. This could be anything. Of course, the odds that you're interested in historical maps of Portland, Oregon are pretty small, but the point is in the simplicity of this approach. It's very, very easy to upload your own imagery to the platform. I kind of skipped over that step in my description because really it's just a drag and drop in Mapbox Studio. That's all there is to it. And the result, if you follow the tutorial, is, again, this map that we're looking at here, which contains no Mapbox imagery. I'll just say that again. This is not Mapbox imagery. This historical map represents your imagery that you have created or bought or sourced from the public domain and uploaded to your account under your privacy settings. I emphasize this because I think it's important to understand that there's a vast range of possibility on our platform just within your own imagery. I am here to tell you about what you can do with our imagery, but that's truly just half the fun. Incidentally, if you're looking at this example and thinking that one 30 megabyte map isn't representative of the scale of imagery that you're working with, that's great. Use our Uploads API. The limit per transfer is 10 gigabytes, and it's easy to automate. I think you can see there the example request is actually with curl, which all you Unix nerds will immediately recognize. If you start bumping into the limits there, you can come talk to us. When we purchase imagery for our own use on the base map, for example, we regularly have to work with terabyte scale renders. And for customers who have similarly outsized needs, we're happy to expose our internal tools to manage these really enormous imagery data sets. That's a significant part of our work. Now, I said we wanted to cover a wide range of applications here, so now let's look at something completely different. If you use Snapchat, what I'm about to show you will be familiar. If you don't, you can ask a teenager. Snapchat includes this really mesmerizing feature called the Snap Map, which lets you browse what people are posting in real time. You'll see a lot of parties and concerts on here, and also sometimes major news events, first-person coverage of things like tornadoes or beautiful videos by tourists. It's really a lot of fun to browse. You can see it styled in this very friendly, colorful way, emphasizing landforms more than borders and place names. But what I want to show you is what happens when you zoom in. At the highest zoom levels, the vector map fades out. Points of interest, like museums and restaurants, pop up, but also imagery fades in. At coarser scales, this is not an imagery map at all, but as you get into finer detail, it becomes one. The imagery is carefully washed out, which we provide styling controls to do, so as not to overwhelm the color of the rest of the interface. And I think it's useful to think about why this is, why imagery fades in as you get close. Imagine being out interacting with the world, whether that means a club or an art gallery for you. When you're at the kinds of places that tend to light up on the snap map, you don't want to see a vector map with a little point of interest icon and a building footprint to tell you where the Eiffel Tower is, or where the Sydney Opera House is. You want to actually see the thing that's in front of you, the Opera House or the waterfall itself. And that's the power of imagery. That is what Earth actually looks like. When you use imagery in your design, what people see on the map can look like what they see in the world. That helps people be engaged with what's around them in a subjective and aesthetic sense, like you'd want a map for, let's say, real estate or a ski slope or a tourist map, but also in a very practical sense. One of the things we see in our maps in the wild is that when people get into central business districts in cities with a lot of tall buildings, they often switch from a pure streets view to something that shows the buildings around them. Because when GPS struggles, or you're not familiar with all the streets and the scale of things, you want to know how the place looks. You're navigating partly by landmarks. And that's part of what imagery can show you. So in fact, a lot of the use of our imagery-based map out there in the world is with a light overlay of street names, points of interest, and other simple vector data. Like here, you may or may not need a label to know which bridge is London Bridge. But it's good to know the name of the route that crosses it and the name of the ship anchored near it. We relatively rarely see pure imagery-based map applications. A lot of the time, imagery is most useful in combination with vector data, like street names. And in my opinion, vice versa. Here's another simple example. This is a 3D view using elevation data under imagery. If this is interesting, we have demos showing how to make your own and how to plug it into an app or a game. 3D is great for all kinds of outdoors maps. Anything to do with hiking, skiing, fishing, kayaking, hang gliding, you name it. Roughly 150 million Americans participated in outdoor sports this year, and we spent about $15 billion on clothing and gear for it. Many of these sports involve some kind of climbing or descent, or for that matter, avoiding climbing and descending. And yet, if you look at the apps out there, many of them only just started integrating 3D. That's kind of surprising, and I expect to see it change quickly. And one of the things about 3D is a plain vector map is going to look kind of silly in 3D. Imagine that here, a street map draped over this elevation. For one thing, it'll be mostly blank and featureless in the areas where many outdoor sports take place. You might have elevation contours and a dotted line for a trail, and that's it. And that's useful information, of course, but think about how much richer an experience you get from a view like this. You can navigate by what things actually look like, as well as in other ways. Here's a real example from All Trails, one of our customers who I use many weekends. This is an example of a trail with a vector map. Now, this is a beautiful vector map that I admire a lot, and it's an essential part of planning a hike. It gives a great sense of things like elevation gain. But it's really not telling me what the hike is going to be like in one very important sense. I don't know what I'll see. Whether I'll be in a forest or an open place or what. So I switched to the imagery map. and it fills in that information. Now, for me, as an end user of this product, I know that I now have a much better sense of, for example, whether I want to do this hike in the rain. This is a pattern we see a lot. Imagery should not be the only map, but it's very complementary. It adds value to the core product, and because from a programmer's point of view, it's just another map layer, the technical lift to implement this is virtually nil. Now let's jump to another topic, algorithmic use of imagery. What we've been talking about so far is basically about how to use imagery in ways that end users will see and understand in an everyday, interactive, transparent way. But there's a whole other class of things you can do with imagery, and that's using it as input data to any of a variety of algorithms, from classical computer vision to cutting-edge machine learning models. Here's an example from, Here's an example from Ryan McCullough, who's done style transfer using our base map. He's basically using a machine learning model to take the imagery on the left of Crater Lake and apply the brushwork, the style of the painting in the middle, to make the restyled version of Crater Lake on the right. Let's zoom in on that. The real data is on the left, that's straight from our base map. The target style is in the middle, and the output's on the right. You can see he even has some example code here. Now, one of the things we've worked hard on at the imagery team at Mapbox isn't directly visible on the base map. It's making sure that we can provide the rights, the licensing, to do creative experimentation. That's actually really rare among people providing face maps that include commercial imagery, and it's something we're really proud of. One of the key things this helps enable is feature extraction. Basically, feature extraction means deriving your own information from imagery. Now, although many forms of experimentation and academic or nonprofit use are completely free, for commercial purposes, feature extraction is a separate product from the imagery-based map itself, so you should talk to our salespeople who will set you up with a fair deal at anything up to and including global scale. Of course, if you upload your own imagery, then it's between you and whoever you licensed it from, or maybe it's open data. Basically, our point of view is that many people will be completely happy just analyzing their own imagery. But as they scale up, most larger projects will hit a point where it makes sense to talk to us about using our base map, and we're here for that. With any questions about anything I've just said, our salespeople are here to help you figure things out or refer you to the imagery team. Feature extraction covers many different techniques and applications. I'm going to limit my examples to basic land cover classification and building footprints, which are some of the more common uses. This is an image showing imagery on the left. It looks like a kind of fuchsia pink for buildings, salmon orange for roads, green for parks and open spaces, and blue for everything else. And then on the right, very faintly, some cleaned up and squared off polygons representing just the buildings. This is output from RoboSat, which is a good place to start if you're curious about this kind of use. RoboSat is a free open source tool oriented towards satellite and aerial imagery that uses machine learning for what's called semantic segmentation, which is a way of doing feature extraction. RoboSat is not the most advanced option out there, nor is it the most optimized. But it's well designed and well documented, and it makes an excellent starting place for learning and experimentation. Among other things, it's very flexible and easy for an intermediate to experienced programmer to adapt to different purposes. It's also packaged in such a way that it's easy to run locally just on a laptop to run experiments. Again, RoboSat is not the most advanced tool out there, but it's an excellent introduction to the domain and an equally excellent text bed if you're itching to try a new idea. So here we're seeing RoboSat detecting the streets. You can retrain it to detect pretty much anything within reason. That's kind of its design goal. You can see that this particular model isn't perfect, but it seems to be getting fairly accurate and will likely converge well with more training. In its default configuration, when you ask RoboSat to train on an area, RoboSat will download building footprints from OpenStreetMap, and imagery from Mapbox's base map, and train a model to match them. And if you want to use some other sorts of footprints or any other input data, it makes that pretty straightforward. What we're looking at here is not just a specific model trained to recognize buildings. It's a generalizable pipeline for doing a really wide range of semantic segmentation and comparable tasks. For many of these tasks, the hardest part, or at least the most time-consuming part, is the extraction and cleanup, which RoboSat helps with. So if you're interested in automated mapping of anything from swimming pools to power lines, but you need a starting place, RoboSat is great. And we're here with our experience to talk you through large and complicated projects in this domain. This is obviously only a tiny pinhole view into the world of feature extraction, but for that matter, we've only scratched the surface of 3D, for example, or ways to combine imagery with streets data. This is necessarily a whirlwind tour of imagery. So with that, I'll wrap up the presentation portion of this webinar and get to questions. But first, I want to remind you of the single most important point here, which is that imagery is what Earth looks like. This is the fact that makes imagery valuable across all these quadrants we saw. Imagery that you upload, imagery that we provide, in situations where imagery is merely complementary, and in situations where imagery is the focus. We could add more dimensions. We could say that this applies in situations where users are looking at imagery directly, and equally in situations where you might be training a GPU to analyze it. The value of imagery is that it lets you interpret it for your purposes and make the map that you and your users need. And with that, let's go to questions.
Great, thanks, Charlie. If you have any questions, go ahead and submit them now. So Mike wants to know what the resolution of our satellite-based map is.
Good question. It varies by area. It's higher in more populated areas with more demand. So, for example, somewhere in Siberia, you could easily be seeing half-meter resolution. Over cities in the US, parts of Europe, I mentioned New Zealand, you'll often be seeing aerial imagery that goes down to just a few centimeters at best.
And what's the highest resolution?
I think we have some 7.5 centimeter on the map. I have to check that though.
What are the imagery sources for our base map?
At last count, I think there are about 20 of them. I would say the bulk of it is from Maxar, formerly Digital Globe, which is the premier seller of commercial satellite imagery. Beyond that, there's other commercial data, including the aerial data I mentioned in lots of the US. And there's also a lot of open data. So for example, some of that New Zealand data I mentioned is from LINS, the New Zealand Geospatial Authority. That's open data. So there's some open data in Europe as well, and I want to say Hamburg. So essentially it's a very broad mix.
I'm going to combine a couple questions here regarding the roadmap for updates. And do we have any plans for multispectral data, or will Mapbox satellite always be RGB?
Good question. Okay, so addressing roadmap first. In generally, we don't publish long-term roadmaps. And to be perfectly frank, that's because we don't have long-term roadmaps, because we try to buy imagery as it comes on the market. When we see good imagery, we buy it immediately, and we don't. It's hard to plan that. So that's why our roadmap is relatively short. I understand that's not ideal as a customer. Believe me, it's also not ideal for us that we have to it's like a fancy restaurant where there's something that's market price, and they have to go down to the farmer's market to get it, and they can't necessarily tell you whether they're going to have it in a month. So that's why we don't roadmap very much. I wish that we could, but the nature of being able to buy and serve imagery as soon as we can get it means that it's difficult. For multispectral, that's a good question. We don't have immediate plans to have a multispectral base map, simply because although it's important for some users, it's a fairly small group of users who really need that, and we feel that most of them probably have demanding enough needs that they would rather be choosing their own imagery. So for example, they would be rendering, they would be uploading their own, let's say, Landsat, Sentinel-2, MODIS, Sentinel-5, or commercial, Worldview 2 or 3 multiband imagery themselves. So we kind of think that the demand for multiband imagery correlates with the demand for very specific imagery, and it's probably not wise for us to be choosing which multiband imagery you would want.
Do we currently, or are we planning on supporting uploading custom 3D renderings?
I'm not really the right person to field that question, unfortunately, although that touches on imagery. The 3D data sets are not something I can speak to.
Is all the data in the base map licensed to support feature extraction?
So feature extraction depends because we use all these different sources. So imagery that comes from provider A, we might have gotten under slightly different terms from provider B, and we, in some cases, will have to go and check with them. So the answer to that is basically talk to sales about the area that you're interested in, and they will give you the best terms possible.
Where do you believe that our imagery differentiates from Google Maps in terms of both features and allowable terms of service?
I'm not a lawyer, so I think it would be unwise for me to try to interpret terms of service for my company or any other company. But I will say broadly that I think that we are very generous in terms of the things you're allowed to do with our imagery, especially in terms of experimentation and restyling, something that I would love to see more of, that I think that would be fun for a lot of people, is to see people doing on-the-fly restyling of our imagery, changing colors, changing styles. And so remember that style example, that style transfer example I showed? I would love to see someone like implementing that in a browser, so you're actually like panning and zooming through a map that's being restyled on the fly. There's no barrier that I know of to doing that with our imagery, and I think that makes it pretty special.
Why does the satellite tile backend use HTTP 1.1 rather than HTTP 2?
That's a really good question. I don't know. I will pass it on.
Is there a way to get the data, to get the date an image was captured?
Ooh, another really good question. Basically, no. And the reason for that is that we don't have that information from all of our providers. Some do provide a lot of metadata. That's great, and exposing that better internally has been a project for us. If and when we can provide that in a really consistent, useful way, we know that people want that, and we'll work towards that, especially for tracing uses. So, for example, a lot of people use our imagery to trace for OpenStreetMap, and when they do that, they want to know when the image is from, for obvious reasons, to make sure that the map is up to date. Right now, we just can't provide that in a very clean way through an API that always gives you a useful result. But both internally and externally, that's a high priority.
How do I report bad imagery?
Oh, good question. You can, I guess I'm not sharing my screen, just search for Mapbox report an issue, or on a Mapbox map in the bottom right corner, you'll see a little link that says, I think, report a problem or improve this map. Just go through there, it'll route you to the right place.
Okay, great. We'll take one last question here is regarding the frequency of imagery updates. How frequently do we do that?
Oh, good question. It really depends. In very low demand areas, it could at the extreme be literally years. An example of a very low demand area would be, let's say, the interior of Greenland. No disrespect to Greenland, it is mostly just snow, it doesn't change a lot, so we're not going to update there. In higher demand areas like where we are right now in the Bay Area, or let's say New York, London, it'll be up to several times a year as the imagery is available. One reason we don't do, let's say, monthly updates is because in winter you get very long shadows and lots of snow, which is usually not what people want to see. When we do, rarely do an update like that, just because, for recency's sake, we often get a lot of complaints about aesthetics. So it's a balancing act.
And so that was the last one, but this is going to be a follow-up to that one. Like, is there a way to find out the frequency of a specific area?
No, that would fall under the same category as the metadata that we just don't have consistently to expose everywhere. So same answer, that is something that we would like and we hope to work towards, but I can't give you like a date or anything.
Okay, great. So that's all the questions we have. I know we had some additional ones on 3D, but we will follow up with you offline if you asked a 3D question. Thanks, Charlie, and thanks everyone for joining us today.
Thanks, everyone.